Hello, my math friends. This is Mrs. Schlecht, and in this video, we are going to solve two-step inequality. All right, so you know that before we get going, there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision book. Don't forget, we're in volume 2 now. Second, don't forget your math notebook so you can take those beautiful notes and show all of your wonderful math thinking. Third, don't forget your pencil to write those notes. And fourth, last but certainly never ever least, that positive math attitude. All right, my friends, so this video goes very well with lesson 5-6 and in volume 2 of your Envision book. And the key concepts for this lesson can be found on page 302. Now, if you remember, last week we looked at solving these inequalities using addition and subtraction or using multiplication and division. So now we're just gonna combine the two for a two-step inequality, right? So what we'll do is we'll take that constant and we'll either add it or subtract it, and then we'll look at our coefficient that goes with that variable, and then we'll use multiplication and division to solve that. So get your notebooks out because there's going to be something pretty important that you should probably write down. Did you get your math notebook out? I hope you did, because this pretty important, all right? So this does not come from your key concepts page, which again is on page 302, but this is kind of a big idea that wraps up everything that we're doing, okay? So again, I would make sure that I would put this in my math notebook if I were you, okay? All right, so this is our essential understanding, basically what you need to know, the basic idea, okay? And it says to solve a two-step inequality, remember that's the whole purpose of this video, you add or subtract the constant. So I put a purple box around the constants, right? So over here it's adding 10, and over here it's subtracting 8. And then it's in purple over here, but you add or subtract those, right? That's the constant. And then you multiply or divide to isolate the variable. Remember, isolating the variable is when you're trying to get that variable all by its lonesome. You want to get it all by itself, right? So I circled that in green. So multiply or divide the variable, right? So over here, 6 times n. Remember, when you have that coefficient, which is just the number that's next to that variable, that represents multiplication, okay? So this is actually 6 times n. N being our unknown, that's our variable, right? But again, that's showing multiplication. And I put a little smaller square around n to show that's the variable, okay? On this side, we have w, which is our variable, and then we are dividing it by 2. So I know it's written as a fraction, but remember, division, fractions, samesies, right? So this case, we would take w, whatever that is, our mystery number, and then we divide that by 2, right? W is the variable, n is the variable over here. Now you're probably wondering, hey, Schlecht, it says or, right? Add or subtract, multiply or divide. How do I know which one I'm supposed to be doing? Great question. Remember when we talked about the inverse operations, right? The opposite. So what we want to do is we want to undo what we did, okay? So for example, over here, we originally added 10, but I want the inverse operation of that. So how do you undo adding 10? You would subtract 10 in that case, right? And then likewise over here, we originally subtracted 8. But how do I undo subtracting by 8? I need that inverse or the opposite operation, which would be adding 8, all right? And then if we think about this whole multiply or divide thing, remember, those are inverse operations of each other, right? So in this problem over here, we originally took 6 and we multiplied it by n. Again, that's our variable. So to undo multiplying by 6, we would use the inverse operation, which you know is dividing by 6. And then over here, if we used dividing by 2, then in order to isolate this variable, we'd have to undo that division, which would be multiplying by 2, okay? So again, to solve a two-step inequality, add or subtract the constant, that was positive 10, or negative, or subtracting 8. Remember, you use the opposite operation. You undo it using that inverse relationship, okay? The constant, right? There we go. And then multiply or divide to isolate the variable, get the isolated variable all by its lonesome. Because essentially we want to be able to say n is less than or equal to whatever, or w is greater than whatever that is, okay? So again, have that in your notebook, my friends. All right, my friends. So the first example that we're going to be looking at together is number 1 on page 300. All right, here's what it says. Bob Ross, side note, I know in this problem in your book, Bob Ross is not the person we're talking about, but we're talking about art. I'm going to talk about Bob Ross. Okay. All right, so Bob Ross has $25.97 in his pocket to spend at the craft store so he can prepare to make another masterpiece, okay? He wants to buy paint canvas and some paint pens. Notice how they say some paint pens. I don't know how many. It could be 1, could be 2, could be a kabillion. I don't know. It just says some, which is leading me to suspect this might be something that we're trying to figure out, okay? How many paint pens P can Bob buy? Look at that, we were correct. Okay, then there's also a picture that goes next to it, and the picture gives us this information. That the paint pens, which again, we're gonna use the variable P to represent the sum that he's going to be buying, right, that number. It's $3.15 for each pen, okay? So if he gets 1 pen, that's $3.15. If he gets 2 pens, that's $6.30, and so on, right? And then the canvas that he wants to buy, that's 14. Now remember back what we just wrote down for that essential understanding, that essential learning. We talked about a constant, which just stays the same, and then that variable. So in this case, that constant would be that canvas price because he's just buying 1 canvas. It's not changing. It's just going to be $14. But because old Bobby Ross over here doesn't know how many paint pens he can actually buy, the paint pens is going to be our variable because it varies depending on how much money he has left over, right? So now, my friends, let's use this information to write an inequality so that we can actually solve it. Ta-da! An inequality, my friends, that we can use to represent, Bobby Ross's story over here, all right? So essentially what we needed to do was we need to take the amount that the canvas cost, we needed to add that to whatever I'm going to be spending, or Bob, is going to be spending on the paint pens. And I put this inequality sign that means less than or equal to the amount of money that Bob actually has in his pocket, right? Because he can totally spend less than $25.97, but he can't spend more because he doesn't have more, right? He doesn't have a debit card. He doesn't, have a credit card. He just has cash in his little pocket, his little Bobby Ross pocket, okay? So this is kind of the skeleton, if you will, of the inequality that we can use. And then here's kind of some of the meat, the fun stuff that we can put on it, right? So the canvas, that was $14. Where'd you get that information, Mrs. Schlecht? It was in the problem, okay? And then the paint pens. Remember, this is going to be where our variable, that P, is because it's standing in for how many paint pens he buys. Is he buying 1? Is he buying 2? Is he buying 3? I don't know. We're going to figure it out, right? So it's $3.15 for each individual paint pen, and we need to find out how many he gets, right? Then again, these 2 pieces of information added together needs to be less than or equal to the amount of money that Bob actually has, which is $25.97, right? He can completely spend all of his money and have no money left over. That's completely doable. That's why that or equal is an option. But the less than part is also an option because he can spend anything under this amount, but again, he can't spend anything over that amount, all right? Now, if you remember from that essential understanding that you were supposed to put in your notebook, it's that the first part that you needed to do was to undo that constant, right? So right now we have this positive 14, which is actually adding that 14. So again, how do you undo adding by 14? What's that inverse operation or the opposite of adding? You are just so brilliant. You knew that if we are adding 14, the inverse or the opposite operation of that is to subtract 14, right? And remember, when you add 14 and then you subtract 14, that just cancels each other out, right? That's just, it just goes away. But don't forget, in order to keep this having the same meaning and in order to keep this balanced, you need to also subtract that constant from this side of your inequality as well, right? So now let's see, what is $25.97 minus 14? And remember, our paint pens needs to be less than or equal to that amount. So now, my friends, we know that $25.97, and we subtracted that constant, the amount of the canvas, which was $14, leaves Bob Ross with $11.97 that he can spend on those paint pens, right? And don't forget, the paint pens, each one costs $3.15, right? Now, how are we we going to isolate the variable? This P right here represents the number of paint pens that he actually has the ability to purchase, right? We want to get that isolated. We want to get it all by itself. So remember, when we have this coefficient, I know it's a decimal, still a coefficient, right? We're multiplying it by that variable. How do we undo multiplication? Well, we use division, right? So we'll be dividing $3.15 times P by $3.15. But don't forget, just like how we had to make sure that we subtracted 14 from both sides over here, we'll need to also use division on this side. All right, little side problem. We're going to be doing some division with decimals. Decimals in the divisor and decimals in the dividend. Oh my gosh. It's okay. You can do it. It's totally doable. So remember, my friends, what we're trying to do is the amount that Bob Ross has left over after buying that canvas, and we're trying to see how many paint pens he can buy, right? So we took the amount of one paint pen, which was $3.15, and we're going to divide that into the amount of money that he has left, right? Now, when you are dividing with decimals, like a decimal over here, remember, it is A-okay to have a decimal over here in your dividend, right? A-okay. However, my friends, no, can't have a decimal over here. Nope, can't have a decimal over here. So what we need to do is, because I don't want a decimal at all over here, I need to scooch it over twice. And what I'm actually doing when I'm scooching it over is I'm multiplying by powers of 10, right? So if I take $3.15 and I multiply it by 1 power of 10, right here, that would actually be $31.50. Oops, still got a decimal, so I have to multiply it by another power of 10, which would give me 315, right? So I actually multiplied it by 100. But remember, whatever you do to this side, you gotta do over here as well. So if you multiply this by 100 to get it to be gone with a decimal, gotta do it over here, right? So we'll also take this decimal place and move it over twice. Again, when we move our decimal, we're actually multiplying by that power of 10. That's the math magic that's actually making it work, okay? So now we have a new division problem. It's actually going to be 1,197 divided by 315. Remember, it means the same because we followed our place value rules, right, and our properties of equality, which means that we did the same thing on both sides. All right, my friends, so remember, we have, yes, the same digits, right, 315, 1197, but there's no more decimal because we multiplied by 100 to get rid of that decimal, right? But now we're going to do some division. So let's see. Can 315 go into 1? Nope. Can it go into 11? Nope. Can it go into 119? Nope. Can it go into 1,197? Yes, and my friends, I do not expect you to have your 315 timetables facts memorized. Nope. This is when we can just guess and check, right? So let's just try 2. All right, so I'm going to put my 2 above the 7 because, again, it could not go into 1, it could not go into 11, it could not go into 119, but it could go into 1,197, right? So because place value rules are still a thing, we're going to put that 2 above the 7, right? So now we'll have 2 times 315. So 2 times 315 is actually 630. Now we're going to subtract this amount, this partial product that we have from multiplying right here. We're going to subtract that from our original dividend. So my friends, when I subtract those two, I get a difference, or the answer to that subtraction problem is 567. Now wait. Do you notice that this answer is bigger than our divisor, right? Remember, when that happens, that tells you that you can do even more division. I know, whoop-diddy whoop whoop, right? So now that's telling me that 2, not big enough. Bobby Ross can buy more than just 2 pens, right? Let's try 3. All right, so now that we're going to try 3, we're going to put the 3 above the 7, right? Because place value, right? So now what's 3 times 315? All right, my friends, so now when we take 3 and we multiply it by 315, we get 945. And now we're going to subtract the 2. So much fun. When we subtract the 2, our difference, or the answer to our subtraction problem, is 252. Now notice that is smaller than what we got, right? And that means that we can't buy another pen at all. So how can we write this whole thing as an answer with a remainder? So we could just write it as 3 and 252. And I know that seems like a really big remainder, but remember, we were originally talking about money. This was actually $3.15. this would actually be $2.52 as well. But is there a way that we can also just write this as a decimal? The answer is yes. So remember that behind every single whole number, positive or negative, there's a decimal, right? There's a decimal after that whole number and then a kabillion zeros that just go on and on and on and on and on forever and always, right? So I'm gonna put that decimal back in. Remember, it is okay to have a decimal over here in your dividend, not okay to have a decimal over here in your divisor, okay? That decimal is just gonna come straight up. And then remember, we have imaginary zeros all behind here, right? So super fun. Let's bring one of those bad boys down. So now what we're trying to see is how many times can 315 go into 2,520? Again, let's just guess and check. Let's try 8. Notice I put my 8 behind the decimal because that 0 came from behind the decimal, and place value rules are still a thing. So now let's do some multiplication. We're going to do 8 times 315. So my friends, when we do that, we actually discover that 8 times 315 is in fact 2,520. Beautiful. When we subtract that, we get 0, which means we're done. But now, my friends, what does this mean? What does this mean in the context of our original problem? So looking back at our original problem about Bob Ross and his paint pens and his canvases, right? We took the answer from that division problem we just did, which was 3 8/10, right? Now, that's not the price. The price of the pens is $3.15. That's not changing. But remember, we were trying to figure out the number of pens that he was able to buy. And what we discovered was that it was 3 8/10 of a pen. Now, if you're walking in the store like Bobby Ross did, they're not going to give you 8/10 of a pen, right? You either buy the pen or you don't buy the pen, but they're not going to like cut it into an 8/10 of a pen to give you that pen, right? So let's think just like logically, right? He doesn't quite have enough to buy 4 pens, but could he buy 3 pens? Totally, right? So how can we actually write this solution, or how can we interpret what this solution to this inequality actually means? This means, my friends, that Bob can buy no more than 3 pens. He has enough money to buy 1 pen. He has enough money to buy 2 pens. He has enough money to buy 3 pens, but that is it. No more, okay? So when we interpret this inequality solution, which was P, the number of pens, needs to be less than or equal to 3 8/10. Again, think logically, they're not going to give you 8/10 of a pen, right? They buy and sell whole pens, right? So again, this means that Bobby Ross can buy no more than 3 pens. All right, my friends, so the next one that we're going to be looking at together is on page 302, and it's number 4. It's about our friend Joe. Now, Joe ran 3 miles yesterday and wants to run at least 12 more miles this week. Woohoo, great for you, Joe. Write an inequality that can be used to determine the additional number of days Joe must run this week if each run is 3 miles. Then solve that inequality, right? So he's already run 3 miles. His goal is 12 miles, so he's already on his way to his goal. Good for Joe, right? And we're trying to figure out, well, how many days does he need to continue to run if he's running 3 miles every single day, right? Now, you're probably wondering, Mrs. Schlecht, why this problem? Why'd you choose this one? Because there's a fun little picture that goes with it. Now, I'm not going to draw the entire picture because you know my artistic abilities are not that of our friend Bobby Ross. However, I will try to convert it into a bar diagram for us. So here's the Schlecht version of the picture, right? We got that bar diagram. Remember, the first step of a bar diagram is to draw a bar, right? The red over here represents yesterday's run, right? That's the total amount that he's already ran. And then this blank space over here is the number of days. Remember, he's running 3 miles for, I don't know, some amount of days, right? And the inequality that we can use, my friends, to represent this whole little Joe story is the 3 miles that he ran yesterday, that's the red, plus 3 miles for, I don't know, some amount of days. So I use D for days, right? Now, if you look at our original problem, it says he wants to run at least 12 miles. So 12 miles, he reached his goal, but he's also okay with running 13 miles, 14 miles, or anything more, right? But he wants to run at least that amount. That is why I've chosen to use the inequality symbol that means greater than or equal to, right? Because he can run 12 miles, that's that equal to part, but the greater than part means that he can also run more than 12 miles, right? So now we're going to solve this inequality. We're going to try to get D all by its lonesome. We're going to isolate it so we can figure out how many days he needs to run to reach at least his first goal, okay? So I look over here and I see a constant, which is the number 3. We're adding 3. And then I see that coefficient, which is, again, the number 3, times that variable, which is d, okay? So remember, we're first going to take away that constant. So how do we undo adding by 3? We subtract by 3. Remember, you need to do that to both sides of your inequality. So when we subtract 3 from both sides, remember adding 3 and then subtracting 3, that's just going to cancel each other out, right? That's why cancel each other out. And then we'll just be left with 3d, which is 3 miles for, I don't know, some amount of days. Again, needs to be greater than or equal to 9 miles. How did I get 9? Because we did 12 minus 3. Now, remember, coefficient next to a variable, that means multiplication. So how do we undo multiplying by 3? We divide by 3, right? Remember, we're doing that to both sides of our inequality. So my friends, once we've divided by 3 by both sides of our inequality, we find that d needs to be greater than or equal to 3. So what does that mean in the context of our problem? This tells us, right, our solution to our inequality inside our problem, the meaning, means that Joe needs to run at least 3 days the rest of this week to reach his goal, right? Because he's running 3 miles each of those days, right? So 3 plus 3, that's 6, plus 3, that's 9, plus 3, that's 12. Hey, that's his goal, right? So if you think about it, he needs to run a total of like 4 days, but he's already run 1, so just 3 more days. All right, my friends, so there's one more problem that I want to look at together. It's number 5 on page 302. No story, just a problem that we're going to be solving. An inequality, my friends, that we will be solving, all right? So we have 4, that's our constant, plus 6.5x, that's our coefficient with our variable, needs to be less than 36.5, right? So again, first step, we're going to take our constant, which is adding 4, and we're going to undo it. So we're going to subtract by 4. So when we subtract 4 from both sides of our inequality, remember, adding 4, subtracting 4, that cancels each other out. That gets us our coefficient and our variable together, which is really nice. And then 36.5 minus 4 is 32.5. So now we have 6.5 times x needs to be less than 32.5. Now remember, coefficient next to the variable, that's representing multiplication. How do we undo multiplication? We divide. So my friends, we know that x is less than whatever the quotient, whatever the answer to 32.5 divided by 6.5 is. Now I know we got dividing by decimals. Let's do it. We can in fact do it, my friends. Remember, if you are dividing decimals and you have a decimal inside your dividend, that's okay, but not okay if you have it over here on the outside of the house with your divisor. So we need to remove the decimal from here. We just swoop it once, which we're actually multiplying by 10, but don't forget whatever you do over here, got to do over here to keep it equal. So if we swoop this decimal, we'll actually have 65, and if we swoop this decimal, we'll actually have 325. So now, my friends, we can just do some guess and check. Let's try 5. Now notice I put the 5 above the other 5 because place value still matters, right? 65 can't go into 3, 65 can't go into 32, but 65 can go into 325, right? Now let's think, what's 5 times 5? 25. So I put my 5 down here, carrying my 2. Now what's 5 times 6 plus that 2? So we saw that 5 times 65 is actually 325. When we subtract that, we get 0. So that tells us, my friends, that x needs to be less than what number? X needs to be less than 5. All right, my friends, that was just a quick run through over solving 2-step inequalities. If you have any other questions, please let me know.